let's finish up these free response questions. So here's another slope field that I'm just going to give you the values. Like I said in the last video, you could figure these out, but there's 25 different values. I don't want us to spend our time figuring those out when we can just kind of get an idea here. So these are our slope 0. Everywhere x is 0, our slope's going to be 0. Everywhere y is 0, we're going to have undefined slopes. Oh, actually, so no, this is undefined. Sorry, that's undefined. That's 0. These are 1. These are -1. This is -2. +2. So this is 2. This is -2. This is -1/2. This is +1/2. This is 2. This is -2. And this is -1/2. I wish I would have drawn that a little flatter. This is +1/2. So like I said last time, they usually will have some sort of symmetry going on. So there's some sort of symmetry when you make a slope field. It doesn't have to be, but that's usually that's nice. A nice little check that you can use. Sketch the curve, the solution curve that passes through 0, 1. I'll pause. You try to do it on your own. Okay, let's see how you did. So there's 0, 1. That's the point you must hit. Now we're going to follow. It looks to me like these kind of all level off. When you get stuff like this, these are usually some form of asymptote. So this is getting really flat here. And then it goes along. So I'm going to say something like this. And then going this way, I'm going to say something like this. So there's my sketch in part B. Find the particular solution to the differential equation with initial condition f of 0 equals 1. So that means that we probably can separate and go. Let's see if that's true. Yep, looks like it. So I'm going to try to take this thing. I'm going to separate the variables first and then solve it. You try to do it first. Pause if you haven't yet. So I would get y dy equals x dx. There's 1 point. Now I'm going to integrate both sides. So that would be y squared over 2 equals x squared over 2 plus c. I'm going to try to get y by itself by multiplying everything by 2. What's 2 times the constant? No, some other constant. Then I can square root, and I get y equals plus or minus the square root of x squared plus c. This is my, I like to do it in a different color so it really stands out. This is my general solution. Do they want a general or do they want a particular? They want a particular. So they gave us an initial condition. So now I'm going to take the general. I'm going to plug in the initial condition. So 1 equals plus or minus 0 squared plus c, getting square rooted. 1 equals, we could probably do this in our head, 0 squared, that's c. So plus or minus square root of c. Kill the square root, the squared, 1 equals c. So now I get y equals plus or minus x squared plus 1, getting square rooted. Notice I didn't box that in. That's because that is not a particular solution. You have 2 answers there. You have a positive case and a negative case. So we have to now plug back in our initial condition to decide which one we actually want. You could probably guess, but let's just double check. 0 squared is 0. 0 plus 1 is 1. Square root of 1 is 1. I don't want the negative. I want the positive. So x squared plus 1 sketch a solution curve that passes through the point 0, -1 on your slope field. Encourage you to pause here. Try to do that on your own. Let's see how you did. So, what would I, maybe a reddish here. So 0, -1. That's the point you got to hit. And then I've got these asymptote things here again. So this is my part D sketch. C graph. Maybe I should write that, huh? C graph. Same thing in purple up here. C graph. So I put both of those answers on the graph. Find the particular solution. Differential is okay. So same setup. I'm not going to go find the general solution again. We already found the general solution. This one's going to be pretty easy. F of 0 equals 1. Nope. F of 0 equals -1. So -1 equals plus or minus 0 squared plus c square rooted. -1 equals plus or minus square root of c. Square both sides. -1 squared is 1. We get the same constant as we got up here. So why do we actually have different answers? Because we still have to choose between the positive and negative case. So remember, our initial condition was 0. 0 squared is 1. Square root of 1 is 1, but we want it to be -1. So this time I want the negative version of the general solution. Okay. More slope fields. Yeah, this one's quick too. I'm going to help you out here. Help us both out since I already did it. Let's go with a nice green. Okay, so let's see. When x is... Oh, look, it only matters when you put an x in there. So when x is 0, we get zeros. There is no y. That's why I said x is the only one that matters. When you put in 1, you get 1. Put in 2, that's 4/5. Is 4/5 more than 1 or less than 1? Should be a little bit less than 1. So a little bit less than 90 degrees. Then we put in -1. So that's -1. Put in -2, so that's -4/5. So it should be a little bit less steep than 1. Something like that. On the axis provided, sketch the slope field. Done. Sketch a solution curve through 0, 1 on your slope field. Okay. So now I want to go to 0, 1, highlight that point. This is an interesting, I'm going to write myself the note here right off the bat. C graph. Pause it and see if you can do your slope field here. It's a tough one. When I did it wrong. I drew it more like a parabola. But these slopes, a parabola, the slopes would be getting steeper the farther out I get. In this case, the slopes are getting less steep. So this thing should be like leveling off. So it should look something maybe like this. I mean, it's not a sharp turn. So it's not that these slopes are 0. So the slopes are flat. So I got to come out flat on either side. And then I got to kind of level off. Something like this. Something like that would be my sketch for part B. Find the particular solution. That one's real nice because it's easy to separate our variables here. We don't even have any y's, so we don't even have to bump anything over. So dy is going to equal to 2x over x squared plus 1 dx. Now I'm going to integrate both sides. I'm going to encourage you to pause here. You should know how to integrate. I'll do the left side, y equals. You should integrate the right side. Think about how you can integrate that. Well, hopefully you thought of UDUs because we can't integrate this without UDUs. So my U would be x squared plus 1. My du would equal 2x dx. Life is good because I've got everything that I need. My 2x and my dx is going to go together. So I really just have 1 over u. I don't have to make any corrections. So the integral of 1 over u is the natural log of u. RU was x squared plus 1 plus C. Is this a solution? Yeah. What kind of solution? It's a general solution. They want the particular. So this is a general solution. Let's use this general solution to find the particular solution, which will occur when that's at the point 0, 1. At the point 0, 1, y would be 1. Natural log of 0 squared, which is absolute 1, plus c. So I just took 0 and 1 and plugged it in. All right, this is one you got to remember. You got to remember that 1 is always e to the 0th. 1 is e anything to the 0th power. And then when you take the natural log, that natural log and the e to there are going to cancel each other out, and you're going to get 0. This, I'll do it in a different color to highlight. This is the natural log of absolute e to the 0. Natural log and e to the cancel, which ends up being 0. So we get 1 equals c. So we can take our 1 and we can take our constant and our function and now come together to make a particular solution of y equals natural log absolute x squared plus 1 plus 1. That is our particular solution. Now, I was interested at this point to take a look at the function just to see if our sketch was halfway decent, our sketch through that spot. So we have the graph. This graph and this sketch should be the same function. So I was curious at this spot to actually graph it. Let's see how we did. So y equals the natural log. Okay, do I really need the absolute values here? No, because x squared will always be positive, plus 1 will always be positive. So I didn't need to include those. I do need an x, but I didn't need to, oh my goodness. Natural log of x squared plus 1, close it, and then my plus 1 again comes on the outside. And look at this bad boy. I'm going to even make the window small so that we can really be amazed. Huh? Uh-huh. Look at that. Oh, nice. Let's go a little bit farther out. Let's go from -5. Let's just do a zoom 6. Now, it kind of feels like that's a sharp turn, but you remember when we zoomed in there, that was not a sharp turn. If it were a sharp turn, all these slopes would have to be vertical in that slope field because the slopes wouldn't exist. The slopes are 0 here, which means the graph had to level off there real quick. Find the second derivative. So I'm going to encourage you to pause, find the second derivative. Okay, let's see how you did. The second derivative is just the derivative of the first derivative. So d2y dx squared equals. Ooh, how would you derive this thing? How would you derive it? Come on. That's a little quotient rule. So u is equal to 2x. U prime is equal to 2. V is equal to x squared plus 1. V prime is equal to 2x. Now we apply the old quotient rule, I'm going to distribute as we go. So u prime v would be 2x squared plus 2 minus 2x times 2x is 4x squared over v squared, which we can then clean up to be 2 minus 2x squared over x squared plus 1 squared. They did ask us to find this, so we need to box it in. Maybe we should even rewrite it. I'm not going to. For what values of x is the graph of f of x concave up or concave down? Well, think to yourself, what are the situations when f is concave up? What are the situations where f is concave down? So hopefully you said to yourself that f is concave up when f double prime is greater than 0. So I'm going to take my function, f is concave up if f double prime is greater than 0. So I'm going to take my function, I'm going to figure out where it's greater, my second derivative, and figure out where it's greater than 0. 2 minus 2x squared over the quantity x squared plus 1 squared is greater than 0. So as we solve this, our first move would be to cross multiply. But before you do that, you got to check for problems. Do we have any problems with this thing ever equal 0? I would square root. I have a possible problem. But I would equal, if I equal this to 0, I would square root 0, then I'd move over the negative. I would end up with some imaginaries. So while there is a potential for a problem, the problem turns out to be imaginary. So now I have 2 minus 2x squared is greater than 0. I'm going to move this one over. So 2 is greater than 2x squared, which means 1 is greater than x squared. And I hate when they're written like this, so my next move is to flip those around. So now x squared is less than 1. So I have to switch the inequality if I'm going to switch the whole statement around. Now, what would you do to both sides to get x by itself? Obviously, you would square root and square root, but that would cause a plus or minus, which that inequality needs to take into account. So when I square root with a positive, the inequality isn't going to switch around. When I square root with a negative, it is going to switch around. So x is less than 1 or x is greater than negative 1. So what would that actually look like? So f is concave up for all x that are an element of, so this is everything smaller than 1 and at the same time bigger than negative 1. Maybe I shouldn't put this or in here. Maybe I just write that. Okay, so if you're less than 1 and you're bigger than negative 1 at the same time, then you're everything in between. So negative 1 until 1. Okay, I gave you the kind of the groundwork. Let's see if you can do the next part on your own. Let's see if you can do the concave down section on your own. So pause it, give it a try. F is concave down if f double prime is less than 0. So my function, I'm going to cut to the chase here. I'm going to have the same situation where this part is imaginary, so I can get rid of that part. 2 minus 2x squared has to be less than 0. 2 has to be less than 2x squared. 1 has to be less than x squared. X squared has to be greater than 1. Now when I square root, I get x is greater than 1. I get x is less than negative 1. So this is a little different scenario. This is everything bigger than 1, everything smaller than negative 1. Those don't run into each other. Like over here, when you're smaller than 1 and then you're bigger than negative 1, those things fit in the middle between. These are different. Wojo used to call these the horns of the graph because they would go out and out from either end. They would go out this way and out that way. So f is concave down for all x that are an element of negative infinity up to negative 1 union 1 to infinity. All right, 2 more. Can we do it? Can we dig deep here? We got it in us. Yes, we can. Another slope field. I'm going to save us the time again, or you could pause it. If maybe you haven't done one yet, maybe you should try to pause this and try to see if you can make your own slope field. All right, let's see how you did. So whenever y is 1, it's kind of nice. When y is 1, we get zeros. And then when x is 0, we get zeros. So those were real quick. And then I plugged in over here, I plugged in negative 1. That gave me a negative 1. I plugged in 1. That gave me a 1. Now they didn't put a point here, so I'm not going to worry about those. They did put points there. They said 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so I'm not going to worry about those. So what happens when we put in a, there we get 4. Then we get negative 4. So this is a 4. This is a negative 4. Using the slope field for the given differential equation. Remember, that's this. That's a differential equation. It's an equation with the derivative in it, and dy dx is the derivative. Use the slope field for the differential equation to explain why a solution could not have a graph shown below. If you drew a particular solution, it kind of looks like we could sort of start here, doesn't it? Like if I picked here as my starting value, it kind of looks like as I go to the side, my slopes go up, but then as I get higher and higher and higher, then they level off. Then they level off. So there's no way that this could work. I would say something along the lines of F must have a horizontal tangent line at y equals 1 according, oh boy, I just cross that out and start over, according to the slope field. So according to the slope field, your function has to have a tangent, horizontal tangent line at y equals 1, and this clearly does not have that. Find the particular solution y equals f of x to the given initial condition. Can we separate and solve? Yes, we can. Yes, we can. All right, you try it on your own. Pause it. See how you did. Okay, let's see. So I first bumped over the y, which means I had to divide by it. I bumped over the dx, which means I had to multiply by it. So life's pretty good there. How would you derive this? Come on. Okay, this is a u du. Man, you got to see it. If you can't see it, you're up the creek, dude. You got to see it. So this is a u du. My u would be y minus 1. My du would be dy. So do I have to account for anything? I do not. So this becomes essentially 1 over u squared du. Now this is something that it kind of feels like you should do a natural log again, but no, it's 1 over u squared, not 1 over u, which is the same as u to the negative 2, which means we can now integrate that, add 1, so that would be u. I'm going to put u back in there, so y minus 1. Add 1 would be negative 1, divide by your new exponent, equals, integrate x would be x squared over 2 plus c. Math voice? This actually, the solving of this is crazy, crazy nasty. We'll see. I mean, it's not crazy nasty, but it's sneaky. Okay, so I'm going to bump this negative across, and I'm going to flip this back to the bottom. So I got 1 over y minus 1 equals negative x squared over 2 plus c. Now, why shouldn't that be negative c? C is a constant. So we didn't know if it was positive or negative before. If you want to write negative c, feel free. You don't have to. Okay, so my thought from here was I got to get that y off the bottom. And I couldn't figure out how to do that until I realized if I want to reciprocal this side, I have to reciprocal this side. I can't reciprocal this side until I combine these into a single fraction. So that means I need a common denominator. But what's c? C can be anything you want. So I'm just going to make c be something that's over 2, and then I'm going to combine it. So this is going to be 1 over y minus 1 equals negative x squared plus c over 2. Pretty sneaky, sis. Now what's nice about this is I can now flip both of these over. I can reciprocal both sides. Technically, I'm cross multiplying and then dividing, but blah, blah, blah. So I get y minus 1 equals, now at the same time, I'm going to take this negative that's going to be on the bottom, I'm going to bump it to the top. So it's going to be a negative 2. The x squared is going to become the positive. What happened? Why isn't the c switched? Because it's just a constant. I don't even know what it is. It could already be negative and now it's positive. It doesn't matter. It's just something there. And then is y by itself yet? It is not. So our final cleanup. Here we go. No, sorry, that's our final cleanup to get to where? Our general, this is a general solution. We don't want a general solution. We want a particular solution. So now we got to find the particular solution of f of 0 equals 1. Let's take maybe a nice red here. So f of 0 equals 1. No, f of 0 equals negative 1. F of 0 equals negative 1. So that means negative 1 is equal to negative 2 over 0 squared plus c plus 1. I can bump this over, so now this is negative 2 equals negative 2 over, that 0 plus c is c. Cross multiply, negative 2c equals negative 2, divide, so c equals 1. So our actual, particular, I should say, solution is y equals negative 2 over x squared plus 1 plus 1. This is my particular solution. And this was another one where I kind of doubted the graph compared to our slope field, so I sketched it. Let's take a look again. So this is negative 2 divided by x squared plus 1, then a plus 1. Look at this bad boy. Negative, let's go negative, yeah, let's go negative 2 to 2. Oops. Does it look familiar? This is actually pretty sweet, man. Pretty cool. Pretty cool. Pretty darn cool. Find the range of the solution. Oh, man, we cheated a little bit, didn't we? We already looked at the function. But look, let's think about it. How low does this graph reach? How high does this graph reach? Pretty easy. Pretty easy. Range. Range would be the lowest it reaches is negative 1. Oh, it does reach negative 1. Negative 1, and it doesn't quite get up to positive 1. It actually did get down there, right? That's the actual function value. And here we are, the last one. Consider the differential equation, blah, blah, blah. Could I do separation? I could. I could separate these. On the x's provided, find it on the 9 points. So here again, they're going to highlight some. You don't have to find it everywhere. 1, 2, 3, 4, 5, 6, 7, 8, 9. They don't care about the other ones. I'm going to save us some time. If you haven't done this in a while, pause. But I got this to be 1. This to be 1. This to be 1/4. 0, 0, and 0. Negative 1, negative 1. Let me double check this one. 2, 0. So that'd be 0, that'd be negative 1, then negative 1/4. Yeah. Negative 1/4. Find the particular solution of the differential equation with the initial condition f of 2 equals 0. So we could solve this by parts. Now, according to Corpy, he says this would be worth 2 points already. So you sketch that, you got 2 points. He said down here, I'm going to actually draw it over here, this would be worth 2 points. He felt this section would be worth 6 points. And then this section would be worth 1 point. So 6 points here, but there's a lot of algebra going on in part B. We're going to find the particular solution. 1 point is taking the differential equation and separating the variables. So the first thing I'm going to do is rewrite this as 1 over y minus 1 dy equals 1 over x squared dx. Now I'm going to integrate. This is a u du, but the u and the du are going to be the same. sorry, the du and the dy are going to be the same, so I'm just going to jump right to natural. If you need to UDU it, go over to the side of the paper and practice. I've been doing this a long time. I don't need to still practice. You do. You do. Get it? You do you. Okay, this is not one that we have to UDU. This is nice. This is x to the negative 2, which means I can add 1, x to the negative 1, divide by my new exponent, plus c. Let's clean this up a little bit. So this would be the natural log of absolute y minus 1 equals negative 1 over x plus c. And this is not yet a general solution because y is not by itself. So we got to first go after y. I can't get to the negative 1, so I'm going to take care of the natural log first. Absolute y minus 1 equals e to the negative 1 over x plus c. Notice how I grouped that so I wouldn't lose anything. Now, this is that trick. You can go two ways here. There are two ways to finish this problem. You can either change this into a plus or minus, or you can use this trick that allows us to separate e to the x plus y gets to separate into e to the x times e to the y. And that's so helpful here because e to the 1 over x is, but then e to the c becomes some constant, which can just be written as another constant. So y minus 1 equals e to the c, I'm going to write it out this time, times e to the negative 1 over x. E to the c is some constant. And now when I get rid of the absolute values, I have to make this plus or minus c, but we don't know what c is, so we don't care what c is, if it's positive or negative. So I can just roll the positive and negative into the c, and then I'm going to bump over the 1. So c times e to the negative 1 over x plus 1. This is our general solution. Now, if you wanted to do this with the plus or minus, it's fine. I'll even indicate to you the spot where you'd have to identify the positiveness or the negativeness. So now we have a particular solution. So I'm going to grab a different color. Let's go with a green here. So our initial condition is f of 2 equals 0. Why do I do it there? Why don't I do it over here with all this space? F of 2 equals 0. That means 0 equals c times e to the negative 1/2 plus 1. So I'm going to bump over the 1. So that's negative 1 equals c times e to the negative 1/2. Then I'm going to divide. So I get negative 1 over e to the negative 1/2 is equal to c. Can we clean that up a little bit? Do you see that cleanup? This e is on the bottom, but what kind of exponent does it have? So if it's on the bottom, I can bump it back to the top and make it a positive exponent. So this would become negative e to the 1/2, and e to the 1/2 is root e. So let's now take this and merge it with our general solution to get one last color, maybe orange. So we would get y equals negative root e times e to the negative 1 over x plus 1. Box that bad boy in because that is our particular solution. The last one for this section, 5.2, for particular solutions, y equals f of x, described in part B, find the limit as x approaches infinity. So what we did in orange there's our function. So we want to find the limit as x approaches infinity of negative root e times e to the negative 1 over x plus 1. Might seem a little scary, but just think about what would happen if the x value gets bigger and bigger and bigger and bigger and bigger. So if I'm looking at this thing, I'm going to highlight where is this going to go if you put infinity in the bottom. In other words, if the bottom gets bigger and bigger and bigger, if the bottom of a fraction gets bigger and bigger and bigger, the answer gets closer and closer and closer to 0. So this is headed towards 0 as x is headed towards infinity. So that means that this is basically becoming e to the 0 plus 1. What's e to the 0? What's anything to the 0 is 1. So negative root e plus 1. Maybe we want to flip it around to make it look a little nicer. We get 1 minus e. And we get a nice little smiley face because that's all flipped around and looks like a multiple choice answer. All right, folks, that was a lot there. Look at the scoring. Interesting how they value the pieces. I wonder where the 6, I know that's 1 point and that's 1 point. I wonder where the other 4 points come from. Maybe 1 point for the general solution, 1 point for that. There's probably some little mix-up along the way in there. But anyway. All right, folks, so that's it for notes. Hopefully you've been digging into the homework and trying to get some of that done. But if not, here's your chance. Good luck.